Hi, welcome. All right, let's try to do this. It's been an adventure. All right, let's get started. Today we're going to start talking about compound interest, okay? I'm going to remind you that you need to get your graphing calculator rented from the library. If you don't already have one, I'm going to suggest TI 83, 84, whichever one they have, it's going to work. They all pretty much have the same keyboard, so be sure to do that. Let's get started. So we're going to start off with an idea which is a very valuable skill that you'll use not only in this class but in your science courses as well, and that's isolating a single variable within an equation. All right, it's super valuable because it cuts down on mistakes that you make when you're running things in your calculator. It cuts back on you making errors when you're solving equations, when you already have numbers, big ugly numbers or something in it. It just kind of might not look simple or more simple, but it actually does improve the situation. So these are called literal equations. Solving these kinds of equations are called literal. So let's look at solving a literal equations. First, you identify the variable to be isolated. Now we've got an example over here, so let me find my pen, which is always hard the first time out the barrel here. And I'm going to isolate the variable we're going to solve. And I like to always isolate variables with a highlighter so I can kind of keep my eye on the prize. If it's a whole bunch of letters, sometimes it's hard to keep your eye on it. When it's a bunch of numbers in one letter, it's easy, it stands out. But if it's a whole lot of letters, you know, it's a little bit harder. The next thing it says is move the addition and subtraction first. Well, if you take a look at this problem here, we don't have anything that says like plus k or anything like that. That would be addition or subtraction, and we don't actually have that here, so we don't need to do anything as far as that second step goes. Next, we're right here, and it says last step is separating the division and the multiplication. Well, if we take a look here, what's happening between the P and the R and the T, the operation is multiplication. And you might remember from all your algebra classes you've had coming here to this point in college is to work algebra problems, you undo things by doing the opposite, right? And the opposite of multiplication is division. And the other thing we need to remember is for algebra, what you do to one side of the equation, you absolutely must do to the other side of the equation. No questions asked. If you don't, you've broken the rules and no longer is it solvable, okay? So here we can see the P is multiplied by the R, which is multiplied by the T, and so we're going to divide both sides by what we don't need. This is where the highlighter comes in play, because we know we don't need anything that's highlighted, and whatever we wrote down here, we write down here because everything is fair. Now the final step, which is often the most important step, to be quite honest with you, is to rewrite the problem all cleaned up and pretty so you can then use it later and it's not a garbly mess with a whole bunch of things that you crossed out. So now I'm going to finally write our solution here, which is this literal equation, solve for R, and it's going to be R is equal to I over P divided by T. All right, so let's look at a couple more. These are equations that we're going to use in this particular section here. These are financial equations dealing with compound interest and or annuities. So we're going to take a look at this first one here. A is equal to P naught times 1 plus R to the T power. This is annual compounded interest. Annual meaning it only happens one time a year. We'll be talking about compound interest that's not annual compound interest, but any kind of compound interest moving forward. But for right now, we need to solve this equation for this P naught. And you might think that all this looks terrible, Dr. Kelly. Look at all this other stuff. But one thing you need to notice is P naught is multiplied by all that ugly stuff, and all that ugly stuff is nicely contained in a little parenthesis. So what we have to do here is just simply divide away the stuff we don't need, right? And the stuff we don't need here is the 1 plus the r to the power of t. Now, you might not know how to deal with that. That's okay. You just need to follow the steps here, right? We're just going to have to write that down, and whatever we wrote down here that was extra, we've got to write it over here. And then we can clean it all up and write it in this nice pretty form, a over 1 plus r to the power of t. Now notice all the stuff that's in the denominator's got to be careful. Don't get sloppy. It's got to stay where it's supposed to go. Let's look at this other one here and we'll solve it. I lost my, I can't see it. Let me make a mark somewhere. There it is. I can't find it. There it is. Okay. Let's solve this guy. So it's going to be the exact same situation. So let's give you a you do here. I want you to do this. If I can. Oh my goodness. Okay. Here's a you do. I'm going to give you about 30 seconds. More than I've been just wasting time here for you to divide both sides and rewrite it in its correct form. Okay, if you're not done, I don't mind you pausing right now and then picking back up. All right, so here we're going to divide both sides by what is not marked out, what we don't need. And we don't need this 1 plus r over k to the nk power. We don't need that, so that's what we're going to put over here. And our final answer, I'm going to write it in a different color so it stands out. P naught is equal to P sub n over 1 plus r over k to the nk power. All right, cool. Let's get into the brass tacks here. If we take a look at this, this is our very first little step, and we're not really going to do hardly anything with simple interest, but it's a good place to start. It's certainly a nicer formula than what we're going to really be dealing with. Simple interest, like I said, is rarely used, but let's learn what all these little pieces and parts mean. So first, this I is the interest. Okay, then P naught here is the initial money invested or borrowed. It's often called the principal. R is the interest rate, and it is very important to note that the interest rate must be converted from percentage to decimal. Right? Remember I said in the last lecture that you can't do any computations whatsoever when it is still in that mode. You can't do any computations. And then T is time, and time is measured in years. And it's important for you to remember it's measured in years, because if I say 6 months, that's equal to 0.5 years, and we just need to make sure that we're paying attention to that. Okay, so let's do this really quick little example. Now, one thing that I always do when I do any problems like this is I like to write down the information that is given to me. Okay, and so what I do is I write down all of the variables. So here we have 4 variables. We have I, we have P naught, we have R, and we have T. And now I'm going to just pick that information out of the question. So it says, how much interest will you earn? So it's wanting to know how much interest. So that we don't know. On $1,500, well, that is how much money we're earning interest on. So that's the principal. in an account paying 3%. Remember, you have to write as a decimal. And time, it's annual, so time is equal to 1. We'll talk about all those little words here in a second. So all we need to do now is just plug this in. So I is equal to 1,500 times 0.03 times 1. I'm going to run that through the calculator real fast. I will be showing you, not in the most sophisticated way, but it'll get better, ways to, the way to do this on the calculator. So that leaves us with $45. Now notice this is a word problem, so we would say the interest would be $45, okay? And then I'm also going to, moving forward, I'll be showing you how to do the calculator steps, and I'll be kind of writing them down also. All right. So let's get into the bigger picture, okay? Compound interest, the big banana. And I didn't write the formula down here, but I shall. Compound interest is P sub n is equal to P naught times 1 plus R over K to the NK power. Okay, so let's break down all these little pieces. So P sub n is the amount that is in the account after you've added in all the interest. And the N is of note. The N is equal to the number of years. And you'll see the way that I will show that notation as we go on. It's not really a big deal, but to be noted. P naught, just like with the simple interest, P naught is the amount of money invested. N is the number of years that the money is invested for. R is that interest rate must be in decimal form. Right, so 2.5% is equal to 0.025. Just making that clear. Okay, it must be in decimal form. And then K is a new variable for you, and that is the number of compounding periods per year. So when you have compounded interest, what they do is they take the amount of money in your account at the point of them paying you interest, right? And they take however much money you have at that very moment, and they calculate the interest, and they put that extra money into your account, and now your account has more money in it. All right, now they do that on different time periods. Sometimes it's one time a year. That would be annually, one time a year. It could be 4 times a year. That would be quarterly. It could be every month. That's 12 times a year. It could be weekly. That's 52 times a year. And then we all agree to use 365 for daily. All right, now this is never going to be given to you as a number. It will always be given in the description words. Meaning weekly, monthly, and such. Okay? All right, so let's get to our first problem. Now, let me apologize for this really, really, really low-tech solution that I had to have, that I had to figure out on the fly here. This is a picture of my calculator. I could not get PowerPoint to play nicely with me for me to get it to work. And frankly, with everything that is really going on in my life, I just don't have the capacity to make anything else work. So hopefully by the next unit in a couple of weeks, I will have worked all of this out, but I just couldn't. So we're going to make this work for now. If you need any help at all, seriously, if you need some live help, please go see Danny in the ACE, or go see Mr. Jeff in the ACE, or you could darn near ask any of your other classmates if they are in my class and they know what they're doing, okay? Or holler at me starting next week. I'll have my Zoom office hours, so you'll be able to see me then as well, and we can do some live talking. All right. Okay, so let's get to the problem. So notice I've got the formula written up here. I'm going to write down all of our variables. So P sub n, and in this case, n is 20 years. So this is actually going to be the variable P sub 20. And all the 20 does is indicate that that is how much you have at the end of 20 years. Don't worry if you don't get it. It's really not that important. I don't know why I used a T, probably because everywhere else I've ever taught I've used a T, but here we use N, which is okay, and K. All right, so these are all the variables. Notice 1, 2, 3, 4. These are the same, 5. There's 5 variables in our equation. Now let's roll through here and find what everything is. Now it says, suppose you deposited $3,000 in an account. Okay, that is principal. That is initial deposit. So we're going to go $3,000. Okay, then it says in an account earning 6% interest. So that's going to be 6%, which is equal to 0.06, right? Okay, 6% interest compounded quarterly. So compounded quarterly means there's 4 quarters in a year, so n is equal to 4. K is equal to 4. That's the compounding periods. And then finally, how much is in the account after 20 years? And so n is 20. I usually write it with the n last. I wrote it in the wrong order. So anyway, I'll try to do better. Okay, now what we get to do is what I like to call plug and chug. Okay, please do this part. If you do not do this part, I will not give you credit. If you just take these numbers from this list and plug them straight into your calculator, I will not give you credit. I need for you to show me all this stuff plugged in, just like this, okay? So this is how I'm going to go. I'm going to say P sub 20 is equal to P naught, so it's going to be 3,000 times, because look, there's a parenthesis there, 1 plus. Now, this is a set of parentheses that is not in the formula, but every time you put a fraction into your calculator here, you need to put it in its own set of parentheses, okay? And that own set of parentheses does not take the place of the parentheses that are already there, okay? Those are still stuck there, all right? Okay, now what do we put inside those parentheses? We put R divided by K. So we've got 0.06 over, what was our K? 4. And notice this. This is all to the power of. This is raised to the power of, okay? And so we're going to put that value in there, and it is n times k. So I'm going to put it in its own little set of parentheses, and I'm going to say 20 times 4 and close it. All right, so this is what I want to see. You This is exactly what I need to see for you to get full credit. I will not give you credit, full credit. I will not give you full credit for simply giving me the answer. There are three things you need to show me. I need to, for sure, I'd love to see you list out all the variables and plug in all the things, okay? I'd love that, but I'm not requiring that. I am requiring that I see the formula with all of the variables plugged in, okay? And then I need a full sentence for the answer, all right? Okay, so here we go. We're going to plug this into the calculator. Now, unfortunately, I had technology problems, so this is going to be how it's going to go. And then I'm going to write it down in calculator steps, but I want you to follow me. First, we're going to go 3,000, 3,000 times, here's that parenthesis. You see this parenthesis here? Here's the parenthesis. So you hit a parenthesis. We open up the parenthesis. Now you're going to go 1 plus, and then remember we got another parenthesis here, so I'm going to hit parenthesis again. 0.06 divided by 4. Notice what we have here, a closed parenthesis, then another closed parenthesis. So we're going to close it. We're going to close it again. And then this guy is up here as an exponent, so you need to use to the power of button. And this caret button right here underneath the clear and above the division is to the power of button. So you're going to push the to the power of, then you're going to open your parentheses, and you're going to do your 20 times 4 and close your parentheses. So now I'm going to write those down in the calculator steps, and I'm going to write calculator steps in black. You'll notice that I'm almost always writing in color, but here I'm always going to write calculator steps in black. So the first step is, so these are the calc steps. I'm going to go 3,000. Open parenthesis 1 plus open parenthesis 0.06 divided by 4, close, close, caret, open, 20 times 4, close, and then you hit the enter button, and it'll give you the answer. And when you hit the enter button here, you will get $9,871.90. It was 989 or some crap. Round up. We're dealing with money. 99, and our sentence would be, there will be $9,871.99 in the account after 20 years. Please do not round it to the whole number. Please give me the cents. I need all the way through to the penny. Okay? All right, cool. Let's do another one. Okay, let's set it up here. We've got our P sub how many years? 6. P naught. R, let me see if I can't set this up correctly. K, there we go, and N, there we go. Do be careful with your casing here. If it's a lowercase r, you need to use a lowercase r because there might be something that's a large case r that means something else. If it is a P and it's an uppercase P, use uppercase P, and so forth, okay? Be careful. All right, let's see what we got here. It looks like we deposited 5,000, so we're looking for how much we'll have at the end of the account, but also be careful and be sure to read the full question here. Check this out. It's 2 parts. I'm actually even asking how much interest would you earn, so it's 2 parts. How much will you have in the account after 6 years? And how much interest will you earn? Okay, so you got to answer 2 questions for me here. All right, so let's get back here. P naught was that 5,000. That's our principal. Earning 4.25%. 4.25% is equal to 0.0425. Interest compounded monthly, how many months in a year? That would be 12. And we want this for 6 years, so N is 6. So perfect. Let's do our plug and chug bit. Let's plug it in. So we're going to say P sub 6 is equal to 5,000 times 1 plus 0.0425 over 12 to the power of 12 times 6. And let's get those calculator steps. I want you to be figuring out the answer while I'm writing down these calculator steps. That way you can check it when I write down the actual answer here. So it's going to be that 5,000 times 1 plus, open parentheses, 0.0425 divided by 12, close, close, to the power of, open, 12 times 6, close, enter. Okay, hopefully you got the answer by now. Let's see. It is $6,449.40. And our sentence would be, we're not done yet, but this sentence would be, there is 644,940 after 6 years, and the total interest earned would be, and let's figure that out. Now, if we deposited $5,000 and at the end of 6 years we have $6,449.40, then it goes to figure that we've gained $1,449.40. That is the difference between the P sub 6 and the P naught. Okay, so it's the difference between the total amount in the account minus the amount that you put in to begin with. Okay, so we're going to find total interest. That is total in account minus the principal, which is the same thing as us saying P sub 6 minus P naught. And in this case, it's going to be 644,940 minus 5,000 equals 14,490. So this answer would be 14,490. Awesome, great. Let's keep on going. Now, sometimes we need to know how much money we need to invest to get to a specified value in an account. Like say you wanted to save some money to put a down payment now on a house, okay? And you know you need to have maybe $50,000 and you want to buy your house in 10 years. You can use the formula that I'm fixing to get together here for you to figure out how much money you need to put in the bank every month or every year or every day or however, whatever you want to do, right? Quarter. We got lots of options. So we're going to go back to that first thing that we did here, early times. And this should look very, very familiar because we've already done it. But we're going to take this equation right here and we're going to solve it for P naught. And I've already done it, so in deference of time, You can go back and take a look, but what we did is we divide both sides by what's not highlighted, what we don't need. We want to keep this P naught, we want to get everything else away. So here is the formula. It's looking ugly, I know. Don't freak out yet. It's not that bad. Okay? All right. So let's keep on going here. Let's use this. You need $30,000 in 12 years for a down payment on a house. How much will you need to deposit in an account earning 4.2% interest compounded monthly? All right, let's take a look and see what that's going to be here. Let's write down all of our things. P sub n. Oh, n being 12. My bad. Okay, so P sub 12. P naught, R, K, and N. All right, let's fill in what we got here. It says you will need, that's a future amount, future. You will need 30,000. That's what's going to need to go right here because that's how much we want to have at the end here. You will need 30,000 in 12 years. Oh, let's just write that in there. N is 12 years for a down payment on a house. How much will you need to deposit? So how much will you need to deposit in an account earning 4.2% interest? Remember that's 0.042. Compounded monthly. I know we got 12 months and 12 years. It's okay though. All right, let's plug this in. Hold on one second. No, I've got my phone is blowing up. Hold on 1 minute. Okay, sorry. My mom. You guys know I'm here taking care of my mom who's dying of cancer. Maybe you don't know that. Maybe I shouldn't have disclosed that, but I just did. So let's just finish this up. That's why I'm not around in it. That's why I look a little rough and why things are so frazzled. Since I'm on a break and since I'm like bumming everyone out and everything at the moment, let me do today's attendance phrase. Today's attendance phrase. Remember, you have an attendance quiz that you have to put this exact phrase. Don't worry about punctuation and capitals and all that, but this exact phrase in the little quiz. Okay, so you ready? All right. Penguins secretly run the stock market. So the secret phrase, today's attendance phrase, penguins secretly run the stock market. Okay, so let's finish this up because I need to get this done. All right, here we go. So let's plug this all in. Now notice I'm going to use it in this form, okay? So here we go. All right, so we're going to say P naught is equal to P sub n. So we're going to have 3,000 on top. Actually, let me do this completely color-coded for you because it might make it easier for you to see. And everything that is in red is part of the formula, okay? So let's go 3,000 or 30,000 over 1 plus, these are the parentheses you're going to have to add in, okay? And then, why did I use green? Shouldn't have used green, my bad. These are the parentheses you're going to have to add in. I'm going to use yellow, which is bad, but I'm going to use yellow anyway. These are the parentheses you're going to have to add in. I'm just going to write all these parentheses in, to be quite frank with you, right this minute, okay? And now let me put in the red line here and that. Okay, cool. Now the R, what is R? 0.042. the K is 12, and that's the green 12, raised to the power of N times K, so that is the orange 12 times the green 12. And I'm going to go ahead and give you the answer here. And it is $2,536.81. All right, and let's walk through the calculator steps here. And there's something important I need to show you. We have to insert one more set of parentheses around the entire bottom. If you do not tell the calculator what goes on top and what goes on bottom, it's probably going to give you the wrong answer. It might not, but it just 2 parentheses will guarantee you're doing it right. Okay, so let's get the calculator steps here. All right, so we're going to start off with 30,000 divided by open, 2 open parentheses, 1 plus open 0.042 divided by 12, close, look at that, there's 2 closes, close, to the power of open, 12 times 12, close, 1 more close. If you forget that last close, the whole thing is toast. Enter. Awesome. And then I'll write our solution here. You will need to deposit $2,536.81 a month to achieve your goal. Of 30,000. Okay, awesome. All right, well, we'll get started with the next one. Okay. All right, so how much would you have to deposit in an account that will be worth $20,000 in the account in 8 years? Assume the account earns 6.25% interest compounded annually. Okay, first let's just talk about that. Compounded annually, that always messes everybody up. When it says quarterly or monthly, they remember it readily, but when it sneaks in the word annually, people often forget. Annually means that K is equal to 1. You want it to be annually because your calculations will be simpler. Okay? All right, so let's write out everything here. You have P sub 8, P naught, R, K, and N. Okay, so how much would you have to deposit in an account that it will be worth $20,000? So that means at the end, it will be worth $20,000. So that means $20,000 needs to go here. And it said, how much would you have to deposit? So that's the old question mark. Okay. In the account in 8 years. So N is 8. We determined K is equal to 1 already. And let's see what our rate is. Our rate is 6.24%. So 6.24% is equal to 0.0624. All right, let's crank it in there. So P naught is equal to 20,000 over 1 plus R, which is 0.0624 over K, which is 1, all to the power of 8 times 1. Okay, so that's going to simplify things when we do our calculator steps. because we're not going to need any extra parentheses around here because anything divided by 1 is that number. So here are the calculator steps. Do it with me. 20,000 divided by, remember we're going to have to set one more set of parentheses around here. Open, 1 plus 0.0624. Again, not any parentheses here. To the power of just 8. No need for parentheses here because 8 times 1 is just 8. And an additional final close. When we do that, the answer we get is $12,323.26. So our sentence here would be that we would need to deposit $12,323.26 each year. Cool. Let's keep on going. Now, we've just talked about compound interest, and now we're going to start talking about annuities. Annuities are things like 401k plans, things that you pay into every month but also get interest earned. Compound interest is one payment and then you earn interest on it. But annuities and like payments like loans and stuff, sorry, I got something in my teeth. Annuities are where you continually pay in and you earn interest, and that's the big difference there. Let's take a look here. Of course, the formula looks a little crazy, okay? So this is when you save money incrementally, so like IRAs, 401ks, okay? And there's only one new variable to note, and the new variable to note is this one right here. It's the D, and the D is the amount of the payment, so that's payment amount. Okay? All right, and another thing I want to make note of that really matters here is that when you're paid every 2 weeks, so some people like me, I get paid once a month. Other people might get paid every week. Some people get paid twice a month, like the 1st and the 15th of the month. And then most people actually get paid on a every 2 week schedule. And what that means is every 2 weeks you get a check. Doesn't matter how many days are in the month. Okay? When you get paid every 2 weeks, K is 26. If you were to count it, K would be 26. All right? Okay. Half of 52 is 26. That's how I got it. Okay, let's keep going. All right, so let's look at this question here. An IRA is a special type of retirement account in which the money you invest is exempt from, exempt from income taxes until you withdraw it. If you deposit $100 each month into an IRA earning 6% interest, how much will you have in the account after 16 years? Now, a lot of time people use IRAs to save money for big things like down payments of the house, again, like I mentioned, or if they want to pay for a car out in cash, they will put money into an IRA so they can build that money slowly so it doesn't hurt as bad, gaining it all together. Now the kicker with an IRA is, and with like 401ks and stuff, you have to leave your money in for so long. Like there's a set number of years, usually it's like 6 years, that you can't come in and you can't touch that money for 6 years without a penalty if you have to take the money. So that's just a little background information. All right, let's do just like we do, and let's write down all of our variables here. We have P sub 16 because it's in 16 years. We don't have P naught now, we have D. D, the amount of the payments. We also have R, we also have K, and we still have N. So we've given up P naught for D. P naught is one payment. D is multiple payments. Okay, so that's the difference and why that's different there. Now let's pick up all of our information here. It says, how much will you have in the account after 16 years? That's that, and we've got 16 years, so N is 16. If you deposit $100 each month, so we've got $100 and each month. And then finally, our interest is 6% interest, so 6% is equal to 0.06. Okay, so we're just going to plug and chug it like we've been doing. This one looks a little bit different, but still the same practice. P sub 16 is equal to D, which is 100, open, open. See that? Two opens in the formula. Open, open. 1 plus our R, 0.06, over our K, which is 12, close, that's that guy there, to the power of 12 times 16. We're going to put that in parentheses because it's not multiplied by 1. All that crap minus 1, close parenthesis, all over this R divided by K business, 0.06 over 12. Okay, so calculator steps, a little bit more complicated, but not terribly complicated. Let's write in the extra that you're going to need. You're going to need one set of parentheses around the entire numerator, okay, because we're doing a lot of things up there. So they'll have one set of parentheses there, and then of course we got 0.06 divided by 12. That is a fraction that needs to have its own set of parentheses, but that's all the parentheses we need to write in. Let's get those calc steps. Here we go. Open parenthesis, 100, close, close, 1 plus, open, 0.06, divided by 12, close, close, to the power of, open, 12 times 16, close, minus 1, close, close, divided by, open, 0.06, divided by 12, close, enter. Okay, now let's see what the answer here was. I pre-worked the answer here, example 5, so that's going to be $32,109.13. So we will say after 16 years, the account will be worth $32,109.13. Okay, there's our answer. All right, we're getting close, y'all. I want this to be a you do for you. I'm going to be quiet. I'm going to write in a few things, but I'm going to give you, I don't know, about 2 minutes to do this problem. Okay, like always, I'm going to suggest that you pause this video right now if you have not finished the problem. That way you can finish up your thoughts with it before I start interrupting you. Okay, so pause it if you need to. I'm going to get started here. Let's see. It says Kay is paying into a conservative investment account, only paying 3% interest. If you deposit $5 a day into the account, how much will you have after 10 years? And how much is from the accrued interest? So notice there's one of those second questions here. I'm going to highlight it so we don't forget. A lot of times students lose points on their first exam with me because they don't read the full problem and they miss that second part of the question. Okay, so be careful. Forewarned. Okay, so we don't know how much is going to be in the account. We are to be making $5 payments in. Our rate is 3%, and they call it a conservative investment because the rate is so low. The higher the rate, generally the higher the risk on the investment. So if you find an investment for a low rate, say below 5%, then it's going to be a really safe bet, like you're probably not going to lose your money in the stock market or whatever. K is we are paying $5 a day. So K is 365 and N is 10 years. So let's just write this in. Piece of 10 is equal to 5 times 1 plus 0.03 over 365 to the power of 10 times 365, all that crap minus 1, close the parenthesis, all of that's over our 0.03 over 365. Okay, I'm going to go ahead and give you the answer here, and then I'll write out the calculator steps. The answer is $21,282.07. So here are the calculator steps. First things first, let's write in the ones that we need to add. We need to add a set of parentheses all the way around the numerator so that that is all captured, and a set of parentheses around our fractions. So here we go. Open 5, open 1 plus open 0.03 divided by 365, close to the power of open 10 times 365 minus 1, close, divided by open 0.03 divided by 365, close, enter. And let's see, our solution so far is how much will you have after 10 years? After 10 years, the IRA is worth $21,282.07. But the second part of the question asks how much is from the accrued interest. Now, remember before, to find out how much interest you have, you say how much money is in the account at the end and how much did you pay into the account. Now here we have to figure out how much we paid into the account, and to figure that out, we're going to say $5 a day times 365 days times how many years? 10 years. This is going to give us that number here. And let me crank this in my calculator. I didn't do that part. So when you do that, we have this amount, which is $18,250. This is the total amount you paid in. You actually paid in. Okay, so remember, to find the interest, we take the total amount we got minus the total amount paid in. So our total interest is going to be 21,282 and 7 cents minus 18,250. And let's get what that is. 21,282.07 minus the answer is $3,032.07. So we get 3,032.07. So now we can also cram in here. I'm going to stick it right here. And the total from the interest was $3,032.07. Okay, great. We're getting really close. Two more problems. All right. Well, actually, one more problem and one description. Okay, again, we often need to be able to solve these really ugly financial formulas for the variable we need. Now, you're very, very fortunate, but we're not going to be solving for how long it takes to do this or how many times a month we need to do it, because you guys really just don't quite know enough advanced math for that. But what we can do is figure out how much the payments are going to need to be. And to do that, we need to solve this equation for D. Okay? And the first thing I need to point out is that I can rewrite this problem like this. D times all of this crap. 1 plus R over K to the n K minus 1 all over R over K. We can write it like this because there's something called a commutative law of multiplication. All right, so that means that as long as that 5 stays in the numerator, that is a whole number, that you don't accidentally decide that it's part of a fraction in the bottom, as long as it stays the number it is and it's being multiplied to this big thing, we can pull it out front. And that's what we're going to do here to solve this problem. Okay? Now, I could belabor you with all of the information, but basically we're going to divide both sides by this big ugly thing, and this is what our final solution is going to be, okay? D is equal to P sub n times R over K, all of that divided by 1 plus R over K to the nk power minus 1. This is the formula that allows you to just find out how much payment do you need. Just like our examples before on saving money for a down payment on a house or to pay for a car outright or something like that. Sometimes you want a goal of, say, you're retiring. You want a goal of $500,000. So that would be P sub n. $500,000 would be P sub n, and then you would start playing with all the others and then figure out what your payments need to be. So I mean, it's really useful. But of course, there's software that does it and all that stuff now. But it's really important for you to kind of understand where all the numbers come from and what did the numbers stand for inside of an equation, so you can understand it a little more deeply. Okay, this is the last example, and we're going to get this sucker done here really quick. I was trying for this to be under an hour, and it's just not going to quite make it, but we are going to be close here. We P sub 30, because this is going on for retirement till 30 years. We need a D, we need an R, we need a K, and we need an N. So let's see what we got here. Says you want to have $200,000 in your account when you retire in 30 years. And by the way, I don't really think $200,000 is really enough for you guys to be thinking about what you need in your retirement accounts. Okay, the way the money doesn't value itself for very long in our culture, you should be thinking more like that $500,000 like I was talking about. D, we're trying to figure out what D is. We need to know what that payment is. R, what is the interest rate? That's 8%. So 8% is equal to 0.08. Got to change it. I can't tell you how many people don't listen to me saying that, which is why I say it so many times. K is, let's see, how deposit each month. Remember, K is always going to be given by some sort of phrase that's each month, annually, compounded quarterly, anything like that. It's always going to be written in words. So that's month, that's 12, and this is for 30 years. So let's plug it in and go. So D is equal to 200,000 times 0.08 over 12 divided by open 1 plus 0.08 over 12 to the 12 times 30 power minus 1 close. I'm going to go ahead and write out that solution. It is $134.20. Okay. And let's get those calculator steps. Now, check it out. The numerator has more than one thing going on. It's a couple things being multiplied together, so it needs to go in its own set of parentheses. And the bottom's already got its own set of parentheses. We do need to put a set of parentheses around this one and a set of parentheses around this. And let's get started. So we'll start off with open 200,000, open 0.08 divided by 12, close, close, big divided by open, open 1 plus open 0.08 divided by 12, close, close, to the power of 12 times 30, close, minus 1, close, enter. Okay, and then let's get our answers here. The deposits must be a minimum of $134.20 a month to achieve the goal. Okay, we did it. Yay! Okay, y'all wish me luck. Have a good day.